Welcome to Brash Ag, the farm innovation podcast with hosts Raymond King and Kit Franklin.
Namaste, Raymond.
Namaste. How are you doing today? Good to see you on this fine day.
Yeah, no, it's good. It's lovely fine weather still, hanging on. We're taking a little trip to Warwick Agri-Tech today, and we are joined by Alicia. Alicia, introduce yourself and your job title, and then we'll delve into what you do and what Warwick Agri-Tech does.
I'm Alicia Feledziak. So I'm the business development manager that's working as part of Warwick Agri-Tech under the University of Warwick. And my role effectively is to kind of lead the growth of the group within the university.
Great. So I think many of us listening to this are engineers and technologists. So we've probably all heard of Warwick Manufacturing Group, so WMG. I think we've probably all heard of them. Warwick Agri-Tech might be a slightly newer entity. So could you give us the sort of background and explain, do you have are you tied to WMG at all? Is there any links with that? Or is that just me getting ahead of myself? Why don't you tell us all about it?
Yeah. So we're definitely linked through WMG. Effectively, Warwick Agri-Tech is an agri-tech focused research group and kind of research hub within the University of Warwick. But it spans multiple departments, so WMG being one of them, but also the School of Life Sciences and a few others. And we're effectively trying to combine the sort of expertise and capabilities and facilities that we have across the university and bring that all together to tackle some of the really big challenges in agriculture at the moment, ultimately to provide benefits to farmers and growers. And the kind of origin story of this is it only really kicked off about 4 years ago within the university, but it started from within the School of Life Sciences. It's on our sort of Warwick Crop Centre, which is a sort of 200-hectare farm facility we have as part of the university. But that actually started as a site 75 years ago. It was actually 77, I think, now. It started as the National Vegetable Research Station, became HRI, and about 20 years ago became part of the university. But their focus has always been about developing practical solutions for growers and for farmers. And it was one of our sort of leading colleagues and academics, Dave Chandler from the School of Life Sciences, who kind of figured out 4 or 5 years ago that a lot of what he was trying to achieve would be greatly enhanced with some advanced engineering solutions and support around it. And it was him that really reached out to WMG as a separate department to kind of say, we need your support, and you've got all of this expertise that we're just not utilising, despite the fact we're in the same university together. It's been 75 years of plant science and 45 years of advanced engineering expertise through manufacturing and, working with these automotive companies like JLR and aerospace companies like Airbus, etc. And all of this expertise going on in the same university, and no one ever thought to talk to each other before. It was brilliant that Dave kind of brought those two things together. And it's been this sort of last 4 years where we've been looking at how can we kind of not starting from scratch, but looking at all the expertise that we've developed and built through working, creating the factories of the future for, automotive and aerospace companies. What can we take from that and bring into the world of ag to kind of support some of the challenges that we've got out there?
Yeah, no, fascinating. I mean, I have to say, I got back relatively recently from 6 months working at Mississippi State University, and that was something I found really powerful there. Having spent my whole career at Harper Adams, which is very niche, and we're ag engineers, and there's obviously agriculturalists. Suddenly being in a university where there were dedicated computer scientists and dedicated whatever you can think of, everything was there from a technical point of view that you could go, well, I've got an agricultural problem, and it's a little bit out of my comfort zone. It's a bit computational for me, but there'll be someone in that building over there who could help me with this. And that was such a cool aspect of being there. And clearly that's going to be the similar with you guys, where WMG's got so much capability and so many different specialisms that you can tap into. Yeah, that's really neat. Sort of breaking down those silos and getting everyone working together in the agricultural space.
Yeah, exactly that. And I think I mean, it's been brilliant that we've started off with these two departments, but the university as a whole, it sees agri-tech as one of its key innovation pillars. So it's really exciting, actually, as this grows, how many more of our departments can start to feed into it, as you say. So even thinking about the Department for Chemistry, when we're looking at new bioproducts and things like this, there's more and more of the university that can get fed into it. So yeah, it's been brilliant kind of seeing how we can break down some of those silos within the university, because there's so much untapped potential there that we can pull into ag. I think that's what the space needs right now.
I think it's really interesting and exciting to see that, you can kind of cross-pollinate things across industries and across sectors. And I think that's really, I mean, we've spoken on the podcast before about sort of centres to try and pull those sorts of things together. And, you kind of often you kind of have in your head, well, I suppose with Agri-Tech, you think about Harper Adams, and then sometimes you might think, well, maybe there's some stuff going on in this sort of Oxford Triangle or Oxford Corridor or whatever they like to call it, sort of area. So it's really kind of cool to kind of see what you guys are doing. And I think you're well located in terms of access to real world farming problems. So I suppose how have you found kind of bringing in those real world problems for to kind of apply the innovation and innovative thinking too?
Yeah, I think we've been so lucky with the fact that our Warwick Crop Centre has been operating under its many titles to support growers and farmers for decades. So the networks that we've built up over that time to really understand the challenges of the growers that we have has been so important for us. And then the fact that we actually have the Crop Centre as well means that when we're developing new technologies, or whether there's SMEs of tech that they're developing, we've got a site where they can bring it to us, and it is a real farm environment where they can actually get some of that initial testing validation through, where it might be too early to take it straight to a farm, but we want to make sure that the technology developers that are coming through aren't coming from just a pure engineering perspective with no idea of the real sort of farming challenges out there, no understanding of the kind of return on investment cases that they're going to need to make. So I think we're kind of finding that we're trying to really make the most of our crop centre as that kind of test bed for innovation and for these technology developers, so that we can really guide them to creating solutions that kind of fit for market and are solving real grower challenges as well.
So explain, I guess, what are the sort of size and scope of the projects you're working on, Alicia? Are you going for sort of innovate calls? Is it direct funded by growers or technology companies? Like, what's the sort of mix of projects, and how are they funded and how are they set up?
I think the majority of the funding at the moment has come through government grant funding. So a lot of the work has come through the sort of Innovate UK Farming Innovation Programme type space, because as we're finding, which is completely different, automotive and aerospace sectors, there aren't these giant OEMs with massive R&D budgets that can just go and, ask you to do some direct contracted research for them. And we're working with growers with very, often low profit margins, tight return on investment cases. They don't have the cash to just develop a whole new, robot on themselves. And same with the SMEs. Obviously, they're tackling a really difficult funding landscape. And it's challenge enough for them just to get through to commercialization without having to directly pay for research in the same way. So I think the Farm Innovation Programme has been a massive support in that space. And we've been, our kind of goal is that we have consortiums where we have a grower who is really providing the challenge and the use case and saying, this is my actual need and I need support here. A technology developer that's developing something to solve that challenge, and then our space within that consortium is either supporting that innovation or working on the sort of manufacturing scale-up side of it, and also providing that sort of testing and validation as well. So our whole focus is about how we can get these technology companies from that sort of prototype stage through to commercialization, and then ultimately delivering benefit to the industry. That's our whole kind of purpose here. So we've kind of started in that sort of Innovate UK space, but we're also really keen on looking at sort of regional funding type landscapes as well, because I think the other thing that we're really conscious of is the massive amounts of fragmentation in the industry and how we can kind of create a better front door for industry at the moment. So thinking about regional hubs for Agri-Tech, for example, and trying to link up with people like Harper as well, trying to create that sort of ecosystem so it's a little bit easier for industry to navigate. Because I can imagine, being a sort of grower or technology developer in the space at the moment, it must be so difficult to know who to turn to or where to go or how to get support at the moment. So I think there's a lot of work that needs to be done in that space too.
interesting part around sort of supporting growers. How do you set yourselves up? Obviously, you're kind of developing new intellectual property as you go. How does the organization kind of sit itself relative to, obviously innovation going on for other parties? Do you kind of build yourself into that intellectual property piece and retain any ownership, or is it sort of fully handed over to the grower or whoever it is that's kind of funding the project? How does that kind of work?
So because we're also a high value manufacturing catapult centre, that's as WMG. So our whole purpose really is to support UK PLC. So in terms of the IP generation, our ultimate goal for that is for the company to take that and commercialise it and make it a success. There are cases where we're developing capabilities which is ahead of the curve, and in that case we're holding on to the IP until there's a company that can come along and actually make it a success. So it just depends on the circumstance, but ultimately we only want to protect the IP to make sure that it goes somewhere that it's going to be successful. It doesn't go into a sort of emergent startup that then sort of falls apart and then the IP is lost. As long as the IP makes it to being commercial, that's all we're kind of interested in. But it's not, we don't want to be that sort of commercial entity. In the ideal world, we're supporting the industry to take it through and be successful with that.
It's interesting what you were saying about there isn't that one big OEM who can write a big check for you guys to do a chunk of research like maybe the JLRs of this world can. And that is interesting, and it's somewhere that when Ray and I talk to our American colleagues for the pod, it does come up that they're aware. The Americans are aware of like the Innovate system, and they are quite jealous of it. That it can help these smaller, more niche problems get off the ground in terms of developing solutions, because in America you basically have to venture capital raise to do that, and we've seen some issues with that in the recent years with the sort of Silicon Valley model that, again, because of low profit margins in ag and slow return on investment, the Silicon Valley investment world doesn't seem to work quite that well in ag, and there's been a lot of failures. This is a hot topic for Ray and I. We go around about every other week. We probably talk about it, but that piece you're saying there about the fact that really leaning into innovate, that they are the rest of the world is jealous of that, and it's cool that we can do that here. I think it was also interesting you saying about how the landscape of who do you turn to is quite messy. I mean, you've got obviously the Agri-Tech Centre, you've got Agri-Tech E, you've got obviously the universities, Lincoln, Harper, now yourselves in this space. Maybe we need some sort of higher directory. I don't know. Of who should you turn to at what point, and what does each do? Yeah, interesting. That's an interesting little point there. Cool. So we're going to head out to your glass houses and see some of your team. But I guess actually, Alicia, before we do that, they're clearly going to tell us about what they do and what they work on. What's your background? How have you found yourself working in agriculture? We always like to ask people that.
Yeah, well, starting from being a kid, my best friend growing up was a dairy farmer, so I spent most of my life on farm to begin with. So I was kind of in that environment to begin with. But I went on to do engineering at university. But I still managed to kind of root my dissertation into being around controlled environment agriculture, kind of looking at how you can grow within a shipping container and looking at all the control systems to manage that. I was kind of part of the officer training corps whilst at university as well, so it kind of led me into a sort of defence career to begin with. So I worked across maritime and aerospace. But ultimately tried to find a way to navigate my career back through to sort of the ag space again. So managed to get a position through the University of Warwick into WMG, and slowly but surely managed to reroute myself into ag tech. So it's been brilliant that I've been able to do that, and it's kind of come full circle. But yeah, it's something I'm really passionate about, and I think you'll find within all the team members that you talk to within the Warwick Agri-Tech team, they're there because they really care and they're really passionate about this space and how we can find solutions for farmers and fix our food supply chain. So hopefully that kind of comes through, and you're going to speak to the guys in a minute.
Yeah, really interesting to see your story as well. So that's really good. We always like to kind of see how people outside of agriculture or sort of not necessarily directly from an agricultural background, although got quite a strong agricultural background anyway, have sort of found their way into agriculture or ag tech. So yeah, let's get down to the glass houses and see what the guys have been up to.
You are listening to Brash Ag.
We're now with Harry down at the development glass house, is it?
Yeah, this is the AgriPilot facility for Warwick Agri-Tech. So this is our applied testing space where we can test robotics and prototypes in a real industrial environment. So with dust, with water, with real conditions that you see in agriculture.
Cool. So before we start talking about the first sort of project you're going to talk us through, Harry, what's your background? You're an engineer working here, but what's your background? What's your journey to get into this world of sort of agri-tech, ag engineering, as Ray and I like to say?
Yeah. So my background, I started out with a master's in electrical engineering, actually at the University of Warwick. And from there, I moved to join WMG, our organisation, which is more focused on industry and applied engineering. Through that, I was drawn towards agri-tech as a industry. The technology is very interesting to me. It's about solving a real challenge and a real need for the UK agriculture. So for me, that was a real appealing aspect of it. And then since then, I've been working for almost 5 years now across a range of different projects. We do things like crop monitoring, we do things like robotic dexterity for harvesting, for weed targeting, that sort of thing. So it's quite a range of projects, and what interests me so much about it is that it's very varied and no day is the same in the targets and goals that we aim for.
No, that's just cool that you've that you have seen the enjoyment in the challenges and the reality that agriculture brings, because that's ultimately why Ray and I find it such an engaging place to work. Is that ultimately some of the biggest challenges civilization frankly faces are agricultural problems, and whilst jet fighters and F1 cars might be exciting, actually on a daily basis everyone needs to eat and everyone needs some technology that gets that food to the table. So
I think it's a personal goal of mine to see UK agriculture growing how much we produce in the UK, from being reliant on imports to moving towards something that's more sustainable. And like you said, that's really interesting to me.
So I suppose we've covered off talking about the fact that you're solving agricultural challenges, and we're stood in front of some really interesting looking tech, and at the moment we don't know what it's for. My mind is whirring in terms of what I can see in front of me. There's a lot of aluminium extrude and a lot of actuators and conveyor belts. Could you give us a bit of a run through of what we're actually looking at in your glass house?
Yes. So what we're looking at is our Gaia project, which is about the handling of tree saplings. So trees will grow in a nursery environment and be harvested, and then they need to be graded into different sizes in order to be grown in the forestry ecosystem. So what we're looking at here is a system that can process trees from a year to 2 years old. And once they arrive at this system in the current process, they're manually sorted with something like 15 people a day needing to sort 100,000 to 200,000 trees in a day, which is quite a speed. I've tried to do it myself, and it took me like 30 seconds a tree, and these people need to do it 2 seconds a tree. So it's a real challenge, and we're working with J&A Growers over the road to deliver this solution to help overcome their challenges.
I was just going to firstly say, so J&A Growers, we've also been to see them, we went to see Earth Rover, so again, we're never quite sure when we record these things the order that things are going to go out in, but at some point our listeners would have already heard from J&A Growers, and Jamie there seemed a real advocate for technology, so a great person to work with. Talk us through. We've got on the left-hand side, and Ray will get some photos of this, and I'm sure it'll be on our socials. But on the left-hand side, we've got like an XY gantry with a grabbing arm on it, which I guess is where things come in. There's a conveyor belt, and then there's a different type of robot arm.
Yeah.
You could probably tell me the name of this type of robot arm.
So as you've described, we start off with the whole process. So we start with the gantry system, which is this large 2 meter by 2 meter area, which is able to unload potato boxes of the bundles of trees. So you might have a full box, and then you need to unload that box. The next step after unloading is to place it on the conveyor belt, where it's taken.
So that's a bundle being placed onto this conveyor.
A bundle being placed on the conveyor belt. It then arrives at the cutting station, which is currently decommissioned, but we previously developed this. In the J&A Growers and Jamie's fields, they use tied bundles. It's not the standard everywhere, but for the situation we're working with, we needed to be able to cut those strings. So we have an AI system that's capable of detecting the string, detecting the shape and the position of the string, and bringing a novel end effector that we developed here to cut that string and move on with a spread bundle to the next station. What we come to next is what we call the singulation station, which is this large robot we're looking at in the middle with the SCARA robot, which is a type of robot that can move in 3 axes plus a rotational joint on the end. What the goal of this station is to separate the trees individually, and this is the real bottleneck of the manual process. Because the trees are very tangled together, they're often muddy. They come in with weeds in sometimes, or with other failed trees or split trees. So you need to be able to separate those, and then that can be then graded into 3 sizes. So this was a real challenge for us. We use an AI model to process the bundle, detect where the different trees are, and then position the robot arm to pick them. We are looking right now, we started with a 3-year project that focused on developing the concept, which was to start with a 6 degree of freedom robot arm, which is more like a normal human arm in the way that it can articulate.
Like you see on a factory floor, so.
Yes, exactly like that. And what we've now started to do is we're looking at speeding it up and make it more accurate, because that's how we ultimately get it to be commercially viable. So the robot arm that we now see is a much faster robot arm. It's minimized its joints of movement, so it's much more simple in its motion. And what that means is we can target a time of 3 seconds per tree. So currently this system is capable of separating these trees once every 3 seconds. When it runs really fast, and it's quite impressive how quickly it will do it. But the bottleneck for us right now is accuracy. We're aiming for 80% accuracy, and we're currently around 40 to 50%. And what that means is that we need to do a lot of repicks.
So, what do you mean by accuracy in this situation? Is that picking up 2 at a time rather than 1 at a time?
Yeah, it's a couple of things. There's 2 major issues with it at the moment, which is the depth estimation. So we have a depth camera there that's capable of measuring depth. The problem is 1 camera, so it is limited in how accurate it can be. What we want to do is add 2 cameras, so like your human eyes, you can better detect depth, and that will allow us to accurately pick the tree, so we can get to the right depth without missing it. The second is the double picking, and the way that we overcome double picking is with mechanical solutions. So what you can see here is this press bar system, which is this element here, which currently is not active, but when it is active, it raises and lowers, and that applies pressure to the bundle, which our mechanical engineer, Dan, was working on developing a method for best applying the pressure to pull and separate the trees. We are also working on other mechanical systems to separate the trees, such as a vibration motion. So we might see the arm picking the tree and then doing a zigzag motion to shake the tree off.
Yes, this is all about like what stops everything just getting tangled together.
Yes.
You might grab a single stem, but then if the whole lot just gets tangled together like a big mat of straw, it's a bit of a nightmare. So yeah, this method we're seeing in front of us at the moment is just basically applying a gentle pressure to that whole bundle, so you can pull one out.
It's coming from a similar place to how we might use our hands to separate it.
Yeah.
But approaching it from the hands, you've got so many different joints, is not really a cost-effective way to do this. So what we really need to understand is what are the key constraints that exist in this process, and how can we abstract those to something that's very simple and effectively cost-effective and fast.
I think it's always interesting when you look at sort of systems level stuff like this. So how was the problem defined as such? And did you often when you talk to people and they do automation, the next step is, well, if we completely change your handling system and completely change your approach, we can make it so much easier.
Yeah.
Where did you draw the line at where you said, right, this is the new technology and this is where we're fitting in the old technology? And how was that, was that sort of a customer led?
So the real push for this was the labour shortage. So J&A Growers, they need to be able to fill 15 people to do this process currently. If they are unable to find the people to do with the skill set to separate them quickly, or even enough people to do the job, then they're going to slow down how much they can do. They're also unable to scale up their production in the future if they wanted to do that. So we were led by that challenge of, okay, so we need to reduce the reliance on manual interventions. So we can have a system that's 80% reliable and there's a 20% human element. So if you imagine that we go from requiring 15 people to requiring 5 or 6 skilled operators, so they can be robot operators as well. So it's not just leveling up and reducing the reliance on the labor, but it's also allowing us to have a system that can be robust enough for people to quickly intervene and fix it. That will be a good stepping stone and an achievable stepping stone, rather than aiming for something that's 100% pick and place, and which is going to take a lot of money and a lot of time to get to.
Yeah. Okay. I think what was going through my mind was like, could you take this one step further and almost put the robotics in the field and autonomously harvest, and you could harvest to order almost?
So I think the challenge for that is the rate of harvesting. So we have seen Jamie harvest, and the trees are more like a liquid than a solid. When they're harvested, they come that quickly up a conveyor belt. He's just about has enough time to bundle them up. Some growers don't even get a chance to do that. So it could be something, but I think the challenge is quite high there, and it's better to focus on processing them at the later stage.
Yeah.
They also need to be properly handled when they're harvested, because if they're not stored properly, the trees can die or can be,
Yeah, so the purpose of the singulating them is to be able to grade them and put them into to group them by size and etc.
So mainly to grade them, but also to count them. So if you're fulfilling an order of so many trees, you need to be able to count them, and that helps in that side. There's also a quality control aspect. Like I said earlier, you get weeds, you get Jamie doesn't get many weeds, but when he does, they can be in the system. But you can also get split trees, which aren't desirable to grow. So there's a quality control aspect to it as well. Currently, there are grading technologies out there. So there is a company in the Netherlands, Gijo, which is capable of processing trees when it's passed to them one by one. So you can place one tree on a conveyor belt and it passes over a camera that can grade it automatically.
Sort of human singulation, effectively.
Yeah, so these are fed by humans currently. There are a couple of them in the UK. That's some of the big growers. But the problem is you still need the human element to separate them. And it can't run at its full, it could run a lot faster, with a robot feeding it than a human.
I guess we're speaking to an engineer with you here, Harry. What's been the as a final sort of leaving question on this particular project, what's the greatest challenge that's currently being faced, and therefore, you know, what's the thing that's going to be keeping you and the team who are working on this sort of scratching your heads for the next year?
I think it's the variation. So in agriculture, I've come previously working on manufacturing projects where you have a bearing and you have a consistent size and you have a consistent placement. With this, it's unpredictable. You don't know what shape the tree is going to be in. You've got to be able to deal with that. There's lots of different factors. It's not just species to species as well, so we can train a model to recognize a particular species, but then we have to add another tree to that database. But also within the same tree, you can have differences per season, or even differences in the same season where they might have more leaves when they harvest them earlier in the season versus later. So it's that variation that is a really big challenge in here. And I think that's a common theme across agriculture and our projects, is that we need to be able to cope with that variation and unpredictability.
Well, thank you very much for talking us through it.
Thank you.
So here we're here now with Ben, and we have just seen an excellent demo of a robot moving its way around a strawberry farm in a glass house. So it's been interesting to see that. So could you give us a little bit about yourself and how you found yourself to here, working here and what you've been involved in, and then dive into a little bit about the technology and what you're working on?
Yeah, of course. Yeah. So hi, I'm Ben. I'm a lead engineer leading the Connected Cooperative Autonomous Systems Group. So we historically have done automotive on-road research. So think similar to Tesla, Waymo, and have learned a lot of that over the last kind of decade. And recently, over the last few years, working with Warwick Agri-Tech, have been transferring all of those knowledge, capabilities, learnings into the agriculture environment. The main reason for this being that on road there is lots of people doing lots of strange things, and it's a really, really challenging, complex environment to work in. But actually, if we can come into a semi-controlled environment where we know where all the staff are, we know what's going on, we have some control over it, we can start having these autonomous vehicles working in the real world, creating real world impacts in the near term. So I've been at WMG now for 8 years, did my degree in systems engineering there beforehand, so I've been at the university for over a decade now. And have been loving trialing out this agricultural research.
Amazing. So could you give us a little bit about the specifics of this sort of challenge and how you've applied what you've done from the automotive sector, but for strawberries? What's the problem you're solving first and foremost?
So this project that we've just shown is working with a company called Dynium, who build the hardware, and aim is to be able to do the logistics for strawberry harvesting. So this isn't harvesting the strawberries himself, that's still being done by a human. This is trying to have the earliest, easiest win by adding in autonomy and automation. And that is just moving things from point A to point B, because that is such a common problem across so many different areas. But it seems simple in practice, but actually there's a lot of challenges that go into making that run really reliably and really robustly. I think that my favorite example of this is we want our autonomous vehicles to be like a toaster. Nobody gets excited when their toaster toasted toast, because, well, that's what they do. Why would we be excited that it's done that? Our autonomous vehicles that are driving autonomously should be boring. It should just do its job. And that's, I think, definitely something that we've learned through all of our experiences. Let's start with the easiest, the simplest use case. Let's get that bulletproof, bomb-proof, and then let's slowly add on top of that, and let's slowly build onto that. But once we've got a reliable base product, a base system that will work.
So, yeah, I mean, this is music to my ears. I've probably said it on the podcast 20 times, and I've said it hundreds of times over my career. I got very bored of hearing people talk about strawberry picking robots, because, yeah, if you visit a strawberry farm, a huge proportion of the work is being done in things that are far easier to automate than picking. Picking is incredibly hard to automate because it's exceptionally dexterous. Logistics and sorting are much easier to automate, yet all the money and all the coverage and etc. all seem to get piled into picking. So this is definitely music to my ears. The robot we've just seen running, what sort of is obviously operating in a glass house. This could also be a polytunnel. What systems is it using to operate? I imagine that this might be a tricky environment for GNSS technology. So are we talking SLAM systems using lasers? Are we talking cameras, radars? Tell us about the tech that you've harnessed.
Yeah, exactly. It's a definite challenge. So one of the biggest difficulties is that going between indoor and outdoor. So outdoor, yeah, GNSS, if it's available, works perfectly, works amazing. Great to use. We do use it for the bigger farm navigation localization, but when we're going indoors, then yeah, all the metal work just makes the GPS just not good enough, basically. So what we're using indoors is we're using the LiDAR primarily. So we're creating a map of the polytunnel, the greenhouse beforehand. We're then setting up defined routes so that the vehicle knows where it can and can't go, and then using the LiDAR, we then match what we're currently seeing to the known map beforehand, and we can then work out exactly where the robot is down to kind of centimetre level accuracy to be able to plan out where we are and where we need to go.
Are you also using some sort of, I can't think what the technical term is now because I've gone brain dead, but are you using the sort of odometry stuff as well in terms of, in theory, to get from here to there, I need 5 wheel turns. I need dead reckoning. Yeah, are we using that alongside our lasers?
So we use the wheel odometry. We also use the IMU sensor to get an idea of where we're moving and how fast. And then we also then create some odometry using the LiDAR point cloud by looking at sequential points to look at how the features are changing across that. And then we can then get an additional sense of odometry. And all of that information is all then fused together via the EKF to give us that really good accuracy, because one of these systems on their own is never going to be good enough, or it will drift. So it's like that fusing together is really where you get all the benefit.
Really great. So what sort of level is this tech? Is this still 5 years from being in production, or you said the name of the company you're doing it for?
Dynium.
Is this something they're hoping to get to market rapidly? Or,
so I think they're hoping to kind of ship the first kind of units this year to start doing real world operations, with the aim to then be massively scaling up that commercialization next year. We have a project funding bid in with them to be able to help do a lot of this kind of improving that robustness, improving the usability, the user interface, how easy it is to set up. At the moment, it's quite a tech involved. Need more of a skilled engineer to run and operate, but the idea is that with the next project, that would be something that would be really, really easy and simple. We kind of have the idea of it being kind of a Spotify playlist, so the quality control can just go, right, you need to go to row 1, then after that go to row 4, then go to row 7, then come back to me. But then while at the same time that we have multiple buttons on the robot, so that if the picker was to fill up the robot, then they can just press a button and say, it's full now, please go back to quality control, or send it back on its way.
Yeah, it's really, I like that. I think that's obviously often the bit that gets overlooked is the user interface piece, especially with robotics. People put robots into the field and they've got a laptop in the field. Well, first and foremost, that's a complete pain because you've got things to break, things that get covered in dust, touchscreens that don't work and things like that. So I think thinking about the user interface, obviously a slightly more controlled environment in a glass house, but still the same, you've got challenges in that environment. If you can make it simple and easy to actually to deploy, I suppose it'd be the next stage, I suppose, is the machines sort of almost deploying themselves based on what they know is going on in there, and maybe AI management.
Yeah, exactly. I think going back to what I was saying earlier, the idea is that let's start with getting something that is usable and workable in the current environment, but then ideally we'd then be collecting all that data about how is it used, when is it used, where does it go, so that we can start trying to do these add-ons. What else can we add to the vehicle to make it that little bit more useful, that little bit better return on investment?
Yeah.
Now, Ben, I've met you before a few weeks ago, and I think at that point you were talking about trailers as well in your algorithm. So I think you showed me a demonstration on a video that time of a sort of ground rover with trailer. Talk through the complications of that. Can you reverse your trailer?
So yeah, I think we're really interested in the whole logistics space, and one of those I feel really strongly is a really good use case is the use of trailers, because your vehicle is your most expensive part, so you want to have the utilization of your vehicle as high as possible. Now, if you have a process that takes 5-10 minutes to load the vehicle, you don't want your vehicle to be sat there doing nothing. You want to be able to drop a trailer off that's empty or full and have somebody be doing and working with that. You go off with your robot's still being productive, it picks up a new trailer and is still carrying out tasks. The challenge with that is that the robot knows where the robot is, but the robot doesn't necessarily know where its trailer is. And we all know instinctively that if you pull a trailer through a narrow doorway, you need to take a wide arc because the trailer is going to cut the corner. But how do you teach the robot that it needs to do that? So at the moment in a manufacturing environment, or most other instances we've seen where you're towing trailers, you follow a fixed path. And you always follow that path, and if something gets in the way, the robot just stops and panics and says, I need some help. Which is fine if you're in a manufacturing environment and you know every 36 minutes you need to move from point A to point B, and it's perfectly clear and it's always clean. But in agriculture, it's not always perfectly clean. Maybe a plant plot's blown in, maybe there's some leaves or some trees that are blown in the way. You're going in different places. Someone's parked a tractor in the way. There's a pallet here that's not normally there. It's a much more changeable environment, so you need a system that can adapt and navigate around all of those barriers and all of those challenges without having to have that human intervention, because otherwise you might as well just have a human do it.
Yeah, it's really interesting to see, and the trailer is almost a force multiplier for your robot, your expensive robot platform. I like that. And maybe I'm going to chuck a more philosophical point back at you. Is yes, our agricultural environment is more messy than an industrial manufacturing environment, but does that not say something about what we need to do in agriculture is potentially improve the uniformity and efficiency of our environments?
I mean, it's always a balance. I think, if we were to design a brand new set of infrastructure, then you would design it completely different to how we have the infrastructure now. There's going to be this transition period where we need to be able to take legacy farms, legacy layouts, and enable them to have this automation without having to invest hundreds of thousands or millions of pounds renovating, changing, having concrete paths everywhere and having everything perfect and pristine. So it's a definite balance between, we don't want to overcomplicate with technology, because if we're overcomplicating when actually, if the solution is pave over that pothole, or there's a big puddle here that always happens, right, sort some drainage out and we don't need the robot to be as complicated, then amazing. But realistically, it's some balance half or part way between those two.
Yeah, great.
Yeah, I really like it. I think it's really cool to see that sort of, solve that problem that Kit's always gone on about, the logistics piece. I've had conversations with people around, what's the next steps and challenges for robotics, and I see logistics being an issue not only in the sort of day-to-day, making sure harvest teams are supported, but also putting robots in the field. How do you get them between fields? How do you get them to the right place? How do you make sure they're doing the right thing at the right time? I think there's significant challenges, not only from software perspective, hardware perspective, and also from a business case perspective. So I suppose on the business case piece, I suppose the intention is obviously to get this to market, and I suppose you probably might not know kind of where they're trying to pitch that, but what do you know much about the approach? Is it going to be a service model? Is it going to be a pay for hardware? Is it going to be how do you think that best suits strawberry growers in terms of getting products in their hands and working?
I think the slightly dodging the question is that I think that the biggest thing really is confidence for growers. I think the exact method of whether it's own the hardware outright with a software subscription for maintenance and support, or whether it's just a entire subscription service where we will move and do all the logistics. I think the key is the system going to work? Is it going to work reliably? And can we trust it? And will there be a return on investment? The exact model of how that works, I think, might be different for different farmers, depending on how big they are, what their risk tolerance is. But yeah, for me, the key is building up that evidence base for that confidence.
Yeah, so that's a fair dodge there, and a good response.
So Ben, just to wrap us, did you you went to Warwick to study engineering? Did you see yourself at 16 working in agriculture when you're however old you are now? I won't pretend to guess, I'll get it wrong. But yeah, is agriculture somewhere you saw yourself working?
Honestly, no, but then it's not somewhere I've not seen myself working. It's not been something I'd ever particularly would have avoided or aimed to do. I grew up in rural countryside with a farm at the end of my road, so I've always been around farming. I worked on a farm when I was younger, but then I got into self-driving cars, and then that kind of all disappeared, but then actually it's kind of come full circle and come back around, and I think we're having a much bigger, much better impact in agriculture than we have done for the on-road sector.
Well, that's good to hear, and we're glad to have you, aren't we, Ray?
Always, absolutely.
So we're back with Harry in another section of the glass house here. We're looking at some lettuces in a hydroponics setup. So Harry, talk us through what we're looking at and what's going on in this room.
Yeah, so in this compartment in the AgriPilot facility, we're looking at data collection. So this is just one of a number of different projects that we can run in here. This is currently running with a student with the aim of looking at how nitrogen impacts plant growth. One of the challenge that he's working on specifically is to work to understand how astronauts could grow lettuce in space. We can give an astronaut a basic understanding of how to grow the crop, and if they can understand how to look at the crop and identify nutrient problems with it, then that will be really important for space exploration in the future and growing food in space. So this project, we have a robot platform here, FarmBot, which is able to move this large gantry over the crops. We can attach a hyperspectral camera to it to take pictures of the crop, to look at the input conditions of the irrigation system, and use that to match the inputs to the outputs of images and make engineering decisions based on that.
So I think it's really cool. We stepped in here. We saw some lettuces. We were sort of on a bed frame that everything's been set up for. I didn't think we'd start talking about space, but I assume from the sort of agronomy perspective, there's applications for the not only for space and astronauts, but also for vertical farming. But I think it's also good to see the sort of the use of, I mean, the FarmBot's like an off-the-shelf product, but the use of an off-the-shelf product, but then you guys actually modifying it so you can gather the data and things that you need to build, to work together to build a really interesting data set and an interesting project. I mean, it'd be just interesting to get your thoughts on, what next steps you think there could be for a project like this in terms of, a continued collaboration between the agronomy side and the engineering side.
Yeah, so we want to continue working with the School of Life Science and their students. They can bring very specific biological challenges to us, for us to bring our sensors and cameras to collect the data and build models for detecting those. The things that you need to detect and build an AI model is essentially you need expertise in the forms from the life science, and then you also need a large quantity of data with variety. And what this space allows us to do is we can capture different angles at different times of day, different lighting conditions. You also see the robot arm behind us, which allows us to get up close to different crops and get them from different angles. And that variety will really help us build the models. And along with the trials that we can run with the students, we can control the conditions of the plants and try different stresses, different ways of growing, and really build detailed models with those for detecting things and also diagnosing the health of the crop.
Well, Harry, I think to save all of us a slow and painful death in this heat, we're going to escape the glass house now. But cheers for talking us through it.
Thanks.
So Ray, what do you think of that? We've had a nice little tour around the development space, seen a couple of example projects, and spoke to two engineers who have come to our industry from elsewhere, which is always inspiring to hear.
Yeah, I mean, I suppose my two takeaways: really interesting projects, and digging a bit deeper on the projects piece. Great to see something, sort of through a university, but that's really got a heavily leaning on the applied side of things. So really thinking about the problem, really thinking about how that's actually going to be solved for a specific farmer, Jamie, who we've spoken to. So that's really great. That always makes me kind of happy to see that, because I think sometimes, as a non-academic, the impression you get is sometimes it's research for research's sake rather than actually trying to solve a problem, a direct problem for someone. So that was really cool. And my other takeaway, two really enthusiastic engineers. They were really good spokespeople for the industry or the organisation that they work for, but also actually ag engineers, I would say.
Yeah, I think it was really great to hear I know Ben's passion about, he was talking about his trailers and the fact that a trailer can make a robot so much more efficient, financially efficient for the owner of a robot. And and it, dare I say it, somewhat reminded me of when I used to be in my most vigorous gusto about agricultural robotics as a whole and why it was so important. I sort of saw myself describing hands-free to the various guests we welcomed over the years. I could see that in Ben and his enthusiasm for his ideas and his concepts. So yeah, and that was really great to see, and it was cool to hear new ideas coming through from these guys. I think we just need to make sure that they get strong-armed into being seeing themselves as ag engineers, Ray, and get them into agri, I reckon, isn't it?
Absolutely. I mean, obviously they need to listen to Brash Ag as ag engineers to keep up to date with all the latest and greatest of what's going on in the industry. But apart from that, becoming members of iAgri is a very good way to do that, and also to sort of have it acknowledged that they're experts in the sector that is agricultural engineering.
Cool. So, Ray, well, we're going to wrap this episode here. We've had a lovely day out, and the sun's come out for us now. It's almost too hot. But who are we going to tell to listen to the podcast this week, Ray? Your favourite question of the week?
It's also the listeners' favourite because they get to listen to me squirm as I rack my brains. Well, given it's a very sunny day today, and we have walked past and driven past a couple of ice cream vans. Go to your nearest ice cream van, and whoever's vending out a Mr. Whippy, say to them,
Signor Whippy,
listen to Brash Ag.
Monsieur Signor Whippy, please listen to the Brash Ag podcast, where one day we will probably talk about milking robots if we ever get our act together and cover livestock like we should. Thank you all for listening. I hope you've enjoyed hearing about Warwick Agri-Tech, and make sure you like, subscribe, rate the podcast, share the podcast. Every like and share keeps Ray and I motivated to do this.
Absolutely.
You have been listening to Raymond King and Kit Franklin. Brash Ag. Thank you, and tune in next time.